1.2, we're going to split up into a few different sections because there's a lot going on in this chapter. But the first thing we're going to talk about is arithmetic sequences and series. And arithmetic sequences, not arithmetic, it's the adjective, not the noun, is essentially a linear model. So we have a linear general term. And so we call it arithmetic. There's some kind of constant value that we're adding to each term to produce a new term. So this constant difference is going to be called a common difference, and we denote it with the letter D for difference. So one thing we want to do with arithmetic sequences is try to establish some kind of a general rule so that we're able to determine the general term every time. So let's look at this in general. Let's call an arithmetic sequence's first term a sub 1. So then to get a 2, well, we're going to take a 1 and add that common difference. For example, if my first term was 2 and then maybe my common difference is 3, then my next term is 5. Well, to get a 3, I'm going to take a 2 and add the common difference, which is really just the same as taking, move this over, which is really just the same as taking a 1 and adding 2 common differences. And to get a 4, I could take a 3 and add the common difference again, but it's also the same as thinking about it as a 1 plus 3 common differences. And now it starts to seem like we're establishing a pattern. So let's generalize this. If I have a sub n, then I'm taking a1, and well, let's see what's going on here. When I have my second term, I'm adding 1 common difference, and my third term has 2 common differences, 4 and 3. So n and n minus 1. I'm going to switch from a's to u's here just to be consistent with the book, but an arithmetic sequence then with first term u sub 1, or a sub 1, and common difference d can be given by the general term u sub n equals, u sub 1 plus n minus 1 times d. We're always adding 1 less common difference than the term we're on. We can think about it like steps, right? It takes 1 step to get from a1 to a2. It takes 2 steps to get to a3 from a1. It takes 3 steps to get from a1 to a4. And it always takes 1 fewer step to get where we want to go. So for example, find the general term of this arithmetic sequence. Well, we've already actually started talking about this arithmetic sequence. It happened to be the one that I just gave you above. So let's look at this. The first term is 2. So here's my u sub n. U sub 1, excuse me. My common difference, we can see that I'm adding 3 every time. So my common difference is 3. So u sub n is 2 plus n minus 1 times 3. Let's simplify this. I get 2 plus 3n minus 3, or I get 3n minus 1. So my general term, we could just state it as 3n minus 1. And if you remember from 1.1, if I wanted to express the sequence just kind of as a whole here, I could write it this way. But if I just want the general term, then stating just u sub n is perfectly fine. Let's do something more interesting. Let's work with this formula a little bit better, a little bit more deeply. So the fourth term of an arithmetic sequence is 18, and the common difference is negative 5. I want to determine the first term and the nth term. So let's isolate what I know. I know the fourth term of an arithmetic sequence. Actually, I think I'm going to stick with, we'll stick with u, we'll be consistent. Fourth term of an arithmetic sequence is 18, and the common difference is negative 5. Now, sure, we could work backwards to find u1. We're not that far away, but if I told you that the 14th term was negative 18, that's time consuming to sit and move up by 5, move back by 5 every time. So let's just stick with our formula. Well, we know that we're dealing with the fourth term. And the fourth term is the first term plus, well, 4 minus 1 is 3 times d. And I know that the fourth term is also equal to 18, right? So I've defined this kind of in two ways. I know that the fourth term is 18. We were given that. But I also know that I can take the fourth term and write this algebraically as well. So I've equated the two pieces here. And I also know that the common difference is -5. Oops. So 3 times -5 is -15. And so my first term is 33. Well, this is great because now I can just substitute back in here. And to write my nth term, my general term, 1 times -5. So I have 38 minus 5n. So here's my first term, and here is my general term. So we're starting to manipulate this formula a little bit more. And the last example we'll do with this general term formula is to find the number of terms in the arithmetic sequence given. So again, let's just stick with my general term here, my formula. And we're trying to solve for n now. And we're going to take kind of a different approach. We know my first term is 20. And we know whatever my nth term is, it's 83, right? We know that this is the last term, but we don't know which number in the sequence it is. Is this term number 5? Is this term number 55? We don't know. But we do also know that the common difference is 3. We're adding 3 every time. So here's what we know. We know that u sub n is equal to 83. We know that this is some number term. We just don't know which number term. So 20 plus some number of common differences that we've added is equal to 83. And now it's kind of just an algebra 1 problem. 3n minus 3. So 17 plus 3n. So we're just going to subtract, and I'm not going to make the mistake of trying to do that out in my head. 66 equals 3n, so n is 22. So I know that there are 22 terms in this sequence, and if I really wanted to, I could actually count it up and check if I really felt like it. But we've done the math, so I think we can kind of take our word for it.